Our second lesson in the Similar Triangles unit is on proving triangles similar. We spent a lot of time on proving triangles congruent, so this should go fairly quickly. How do I prove triangles similar? Well, when we talk about similar, we have to talk about a scale factor, okay? And the scale factor is the ratio of the corresponding sides and it's important that order matters. Okay, stop and think about what similar means from elementary school. We have the same shape, but they are a different size. Okay, so let's see here. What is the scale factor from triangle ABC to triangle DEF? So just like with congruent triangles, the order matters here. If I look at AB, that length is 8, and DE, that length is 12, so 8 to 12. I do need to simplify that. My scale factor would be 2 to 3. What is the scale factor from DEF? And this time I'm going to choose EF to ABC and BC. EF would be 15. BC will be 10. Again, I need to simplify that. Okay, notice that these are just reversed even though I chose different side lengths. In order for triangles to be similar, all three pairs of sides have to have the same scale factor. And let's see what happens here with perimeter. The perimeter of triangle DEF, add up all three sides, you get 54. The perimeter of ABC, add up all three sides, you get 36. Oh, simplify that, and that perimeter scale factor is the same as the corresponding sides scale factor. That's going to be important information as we continue on. So what is the definition of similar triangles? And yes, you need to make me a second note card here. Two parts to it. Corresponding angles have to be congruent, and corresponding sides must be proportional. Right? We use the tilde for similarity, and a similarity statement has to match the corresponding angles and sides. Just like your congruency statement had to match your corresponding angles and sides. So let's take a look here. If triangles are similar, their corresponding sides and their perimeters are proportional. And it's the same scale factor, ladies and gentlemen. That is so important. So here we have triangle JKL, similar to triangle PMN. So J and P are congruent. Angle J is congruent to angle P. K and M are congruent. And L and N are congruent. The sides, however, are proportional. Okay, so I'm going to go blue to red, JK, then blue to red in the second triangle, PM. Red to green, KL. Red to green, MN. Green to blue, LJ. Green to blue, NP. So whether you're doing colors or shapes doesn't matter, but matching the corresponding angles is critical to being successful here. So how can we use similar triangles to solve for some angle measures? So let's see, we're told we have a scale factor of 6 to 5. Well, this is definitely my bigger triangle, and here's my smaller one. So 6 to 5, I'm doing the bigger over the smaller. That has to equal x over 28. 5x equals 168. What a pretty fraction. We have, let's see, a to k, g to x, and m to d. Okay. Find the value of x. Alrighty. How about if I do red to blue is 36, and the other triangle, red to blue, is x plus 6. If I do red to green, that's 32, and the triangle on the right, red to green, is x plus 3. Now I know from the last lesson that I better stick parentheses around these expressions before I cross multiply. I'm going to have 36 times parentheses x plus 3 equals 32 times parentheses x plus 6. 36x plus 108. Sorry. 108 equals 32x plus 196. All right, subtract the 32x, subtract the 108, divide by 4. Not bad if I do say so myself. All right, so for your summary, be sure to include the definition of similar triangles,